So till now we have considered how information finds its way into and out of the human system and how it is stored. And now we are going to find out or look at how it is processed and manipulated. So this area is very complex, yes, thinking, but we are going to learn how the human is thinking, how it is processing the information. So humans are able to use information to reason and solve problems. And so here we are going in the thinking part, we are going to see the reasoning and problem solving. So what is the reasoning? Reasoning is the process by which we use the knowledge we have to draw the conclusions or infer something new about the domain of interest. It means reasoning is the process by which we use the knowledge we have to draw conclusions or infer something new about the domain of interest. So there are a number of different types of reasoning, like deductive reasoning, abductive reasoning, and inductive reasoning. So we use each of these types of reasoning in everyday life, but they differ in significant way, yes? So the first one is deductive reasoning. Deductive reasoning derives the logically necessary conclusion from given premises. For example, if it is Friday, then she will go to work. It's Friday, therefore she will go to work. So it's important to know that the logical conclusion from the premises, it may not be necessarily true. If, for example, if it is raining, then the ground is dry. It's raining, therefore the ground is dry. No, so there won't be, it's not necessary to be true, the logical conclusion. This is about the deductive reasoning. Or the deductive reasoning is often misapplied because of the given premises, like when truth and logical validity clash. So some people are babies, some babies are cry, inference, some people cry. Correct? No. So in deduction reasoning, so it's a what? It's an invalid deduction. So it's therefore logically possible that the babies who cry are those who aren't people. So the human deduction is purest. So this is the one of the ways of the reasoning processes. So it allows us to take shortcuts which make dialogue and interaction between people informative but efficient. So we assume that a certain amount of shared knowledge in our dealings with each other, which in turn allows us to interpret the inferences and deductions implied by others. If validity rather than truth was preferred, all premises would have to be made explicit, yes? So that's why this is the deductive reasoning or deduction. Inductive reasoning or induction, it is the generalizing from cases seen to cases unseen. For example, all elephants we have seen have trunks. Therefore, all elephants have trunks. Unreliable. Why? Because we cannot prove. We can only prove false, not true. But of course, it is useful. So we can disprove the inference simply by producing an element without a trunk, yes? However, we can never prove it true, because no matter how many elephants with trunks we have seen or are known to exist, the next one we see may be trunkless. So the best that we can do is gather evidence to support our inductive reasoning. So in spite of its unreliability, or despite the unreliability, induction is a useful process. So in spite of its unreliability, induction is a useful process, yes, which we use constantly in learning about our environment. We can never see all the elephants that have ever lived or will ever live, but we have certain knowledge about elephants, which we are prepared to trust for all practical purpose, which has largely been inferred by induction. Even if we saw an elephant without a trunk, we would be unlikely to move from our position that all elephants have trunks, since we are better at using positive than negative evidence. Here is the second example, Watson's cards. So you are presented with 4 cards, as here in the presentation. Each card has a number on one side and a letter on the other side. Which cards would you need to pick up to test the truth of the statement? If a card has a vowel on one side, it has an even number on the other side. Is this true? So the common response would be here to check what? To check the E if in the other side there is an even number, and check for yes if there is a vowel on the other side. However, this uses only positive evidence. In fact, to test the truth of the statement, we need to check negative evidence. If we can find a car which has an odd number on one side and a vowel on the other side, or if we have a card as a constant and on the other side there is an even number. So we should open all of them in order to disprove this statement, yes, that if a card has a vowel on one side, it has an even number on the side. So how many cards do you need to turn over to find out? We should turn over all the cards, yes. So this is about inductive reasoning. So we are going to generalize from cases we have seen so far. And there is an abductive reasoning. It is reasoning from event to cause. So abduction reasons from effect to the action or state that caused it. So this method is used to derive explanations for the events we observe. For example, here, Sam drives fast when drunk. If I see Sam driving fast, I'm going to assume that he is drunk. So it's unreliable. It can lead to false explanations. Why? Because Sam may drive fast because he is in a hurry. He should go somewhere else. So it is unreliable, yes? So these can lead to problems in using interactive systems. If an event always follows an action, the user will infer that the event is caused by the action unless evidence to the contrary is made available. So in fact, the event and the actions are unrelated. Confusion and even error often results. So this is the abductive reasoning. So if reasoning means inferring some new information from what's already known, problem solving is the process of finding a solution to an unfamiliar task using knowledge that we already have.